Today we're talking about quadratic functions. All right, as always, any good note taker, make sure you have worksheet number 2 written on the top right-hand corner of your paper. Make sure you put today's date. So that way if you have questions later, you can come back to my Canvas page and say, oh, on the 18th, Mr. Street has a video of these notes posted. So I can rewatch that video, okay, if I'm confused. So always write down the date. All right. So goal today, find the inverse of quadratic functions from graphs, tables, and equations. First things first, I gave you some x values, and we can see the dots plotted over on the right-hand side of the screen. So I'm going to highlight those dots. So go ahead and find the corresponding y values and fill out your table on the left-hand side. Take a minute to do that. All right, so hopefully we got our y values written down. I'll go ahead and share what I had with you guys. I had 8, 3, 0, -1, 0, and 3. All right, that's so just remember to find the y values. We go across the x-axis. We count from 0, 1, 2, and then we count up. And I'm counting up to 8 there, so that's how I can find the spot. So -2, 8. Okay. So the next question I have, it says, given an x value of 4, what is the next y value of the original relation? Does anyone have any guesses what they think the next y value would be if we did an x value of 4? Like if we extended this table one more spot. What would the y value be?
8.
Okay, why do you think it'd be 8?
Because it goes up by 5.
Okay, yeah. So you're recognizing some type of pattern, right? So good. So yeah, there's going to be another y value there. This is a quadratic function. If I were to actually draw the function, we're going to see that, hey, it goes up to 8. So that'd be the next value. So if we're writing an ordered pair, we'd say 4, 8. Okay, and the y value equals 8. All right, good. So yeah, that's the idea there for that particular problem. Okay. All right, so inverse relation, exact same thing we did yesterday. We're taking our x values and our y values and we're swapping them. So do the swap. So your x values become your y values. -2, -1, 0, 1, 2, 3. I'm just going to use a highlighter to highlight that. So these were my old x values, and those become my y values down here. And then my old y values, those are going to go on the x column of the new table, the inverse table. 8, 3, 0, -1, 0, 3. All right, that's all we have to do to find inverses. Now, the next thing I want you guys to do, take a minute and go ahead and sketch the graph of the inverse relation on the grid provided. All right, so go ahead and take a minute and do that. This is what it should look like when we're plotting it. So it's like that quadratic function, that parabola. And we saw this a lot in AGS3 last year, except now it's sideways. That's which way is it going? It's going that way. Okay? And there's one very important thing about this. I use a word a lot at the very beginning here, and I kind of threw this around back and forth yesterday, but today we're going to talk about a difference here. But the word I'm referring to is right here, relation. See how it says original relation and inverse relation. There's been another word that we've been using a lot to describe these graphs. Does anyone know what that other word is? It starts with an F. Rhymes with assumption. Nothing? All right. Well, anyway, the word is function, which I have written down here. Okay. And the key here that I really want to point out to you guys is that this right here is not a function. this right here is a function. Okay. Maybe you guys remember this from AGS2. Maybe you remember it from AGS1. Maybe you remember from a different math class. But can somebody unmute and explain why this second graph is not a function? What's wrong with it? There was some type of test we used to do with graphs. If we drew a line straight up and down, do you remember what that was called?
The vertical line test?
Yeah, the vertical line test. What's the vertical line test tell us? Remember, if you see 2 points on the vertical line, what happens?
The graph isn't a function.
Exactly. So the vertical line test, so we can say this graph fails the vertical line test. So you guys might remember that. Something else we can see here is that these 2 points right here, like they have the same first coordinate, the 3 and the 3, and that's another sign that's bad. That's how you can tell from a table. Okay. The same first coordinate. So whenever we have that, that's another way to tell that this is not going to be a function. If you're graphing, I love the visual because you can see that vertical line test, it's going to fail. But if you're looking at a table and they have the same x values, all right, the same first coordinate, then it's not a function. But notice if they have the same y values, like the original relation, then that one is a function. Okay, so it's got to be the x values that are the same to prove that it's not a function. Okay, and that's actually the definition of a function as well. We'll write that down here. A function is a special type of relation. We're just going to say a relation in which no two ordered pairs have the same first coordinate. Okay. What do we think?
No, I mean, yeah, it is a function.
It is a function. Okay. How can you tell?
Because of the vertical line rule.
Right. This passes the vertical line test. So there's only these points right now. This is discrete data. It's not continuous data. Continuous would be if there was a line, but it passes that vertical line test. All right. How about someone from group 5? Tell me about graph B. Function, yes or no?
It's not a function because it doesn't pass the vertical line test.
You guys got it. That's it. It's just as simple as that. I think the mapping's a little bit tougher to recognize for C and D. Oh, there's an extra D there. That's exciting. So let me know if group 2. How about problem C? Function, yes or no? Someone in group 2, step up. Come on.
It is a function because there aren't two coordinates in the x column.
Exactly. There aren't two coordinates that are the same in the x column. There are two that are the same in the y column, but that doesn't matter. It's still a function, so we'll circle that one. Okay? And then last one, let's see, group 7. What do we got on the last one? D. Is it a function, yes or no?
We said no because there are multiple y-axes for the 2 negative 2's.
Exactly. So this one is not a function. That's it. You guys got it. Okay, so multiple inputs to different outputs. That's always a problem. All right, that's the idea there. Okay, moving right along. Page 2 of our notes today. Now we're going to start finding equations of the inverse relations. All right, and finding the equations is very similar, or it's the exact same as what we did yesterday, but the problem now is that we've got this exponent that we have to get rid of, so it's a slightly different step. So first thing we're going to do is we're going to swap x and y, just like we did yesterday. So I can actually, technically, first thing I'm going to do is rewrite this as y equals x squared minus 4 instead of f of x equals x squared minus 4. So when I swap, I'm going to rewrite this as x equals y squared minus 4. Notice the square does not go to the other side. The only thing that moves are the variables. That's key. And then the next step is to solve. So first thing we're going to do is we're going to add 4 to both sides. So x plus 4 equals y squared. And then we square root both sides. And we get square root of x plus 4 equals y. Okay? That's the idea here. Okay, there's just one thing that happens though. And I'm going to show you guys real quick on a graph on Desmos. We have to put a plus or minus right here. That's what's really important from that graph on Desmos that we see. Okay, so whenever you undo a square, all right, you put a plus or minus there. I'm going to write that down over here on the left side. So f inverse of x equals plus or minus square root of x plus 4. There's our answer. And then very important, put in a different color. All right, the plus or minus we only do that whenever we undo a square. And what I mean by that is like we're going to see like problem 2 down below at the bottom of the page here where it says 2 times square root of x minus 3. There's no plus or minus in front of that. And that's how the equation starts. So it's just a positive square root. We don't need to put a plus or minus in front of that. So that's what I mean when I say undoing a square. When you're doing this step in the solving, the blue text over here, when you're undoing that square, you're square rooting both sides, that's when you put a plus or minus in. Okay, that's where it comes from. All right, and that's just so that when we graph the inverse relation, it matches the exact same function that we started with. So the inverse matches the quadratic function. Okay, how to graph inverses? What I would recommend for graphing inverses is to do a table again. It makes it a whole lot easier, and then we can identify some key points. So I'm going to start by labeling some points on my graph. Say it looks like there's one there, and look for some that are crossing some big lines. And we might not need all of them, but it always helps to plot them, or to see if we can pick out as many as we can. So it looks like -3, 5 is the first point. And then we have, the second one looks like it's, what is that? Oh, I put a point over here that doesn't look like we need it. So, because we're counting by ones, so I don't think I need that point right there. I don't think I need that point right there. So good to check while I'm plotting it. The second point looks like it's going to be -2, 0. And then we have a -1, -3, a a 0, -4. for that point. I'll erase that. And then a 1 comma -3, a 2 comma 0, and if we wanted to put one more, we could, which was 3 comma 5. All right. And I always like to do the table first because, again, I personally think that the easiest way to find inverses is to flip the table. I think that's way easier than solving an equation. I think that's the best way to do it when you're graphing, especially, just because you save yourself the time of making a mistake and plotting the wrong point on the graph. I think it's easier to plot the ordered pairs than it is to try and just move one from one graph to the other. Okay, so we've got all our points, and now we can go ahead and plot our inverse relation. So go ahead and take a minute and plot your inverse relation. Once we have it plotted, let's go ahead and connect all the dots. All right, I'm going to put arrows on both of my graphs, actually, the original and the new one. And when I sketch something in Desmos and then put it on this worksheet, it never puts the arrows on there, so I like to add the arrows just because it shows that the function actually goes on forever in both directions. Okay. Now, what we're going to talk about is domain and range of inverse functions. But first, let's talk about the domain and range of the original. So we'll say the domain, we talked about it yesterday. That is the list of possible x values. Okay, and the range is the list of possible y values. Okay. And just like we talked about yesterday too, we're going to use what we call interval notation, which hopefully you guys, I mean, you should have dealt with that a lot last year in AGS2. And that just means we're either using parentheses or we're using brackets, and we'll talk about that a little more right here if we do this. But I'll list my domain and my range. And my domain is all the possible x values. So if I'm looking at my top graph, that's the quadratic function, the x squared minus 4, okay, this one up here, I can plug in whatever number I want for x into that equation. Like if I plug in -100, I can square -100 and subtract 4, and I can find an answer. All right, if I plug in -1 million, I can square -1 million and subtract 4 and find an answer. So what that really means is that the domain is going to work for any x value. It doesn't matter what I plug in for x, it's always going to work. So that's where you'd come up with this -infinity to +infinity. That domain's kind of tricky, and it's really tricky for me to explain this on a screen. It's a lot harder than if I were just in class with you guys trying to explain it. So I don't expect you to be experts with domain and range right now. We're going to get a lot of practice with it throughout the course of the year, but we do need to learn it. So if you're struggling with domain and range, please, please, please come find office hours. This is some prior knowledge that we should know. And I know it's just a tricky concept though. When we're talking about range, that's the y values. And I like to think like we do the vertical line test kind of for x values. We can do a horizontal line test for y values. And with this quadratic function, we'll see that there's a minimum point. And it happens to be right there. This graph never goes below that -4. And that's where we can define our range. Hey, it's going to go up forever. And it can be -4, but it can't be below -4. So that's where the range comes in. And what we'd say there, we have the bracket instead of parentheses. The bracket means -4 is included in our interval. Okay, that's what the bracket means. I can make that arrow a little bit better. Shows it a little better. Okay, so that's how we identify domain and range. But here's what I love about domain and range of inverses. Okay, what's the key that we do when the first step we do when we're solving for inverses? What do we do with our x's and y's? Someone type it in the chat or shout it out. What do we do with the x's and y's when we find inverses?
I'll swap them.
Swap them. And guess what we do with our domain and range? The exact same thing. We're going to swap the domain and range values as well. So the original relation, the domain was negative infinity to positive infinity, and we're going to swap the domain and range. So if we can find it for the original, the domain of the inverse is going to be negative 4 to infinity. The range of the inverse is going to be negative infinity to positive infinity. Okay? All right. The last thing I have for you guys in class today, I want you to find these 4 functions here. Okay, these are all functions, none of them are relations. They should all pass the vertical line test. Okay, find the domain and range of each function, and then write down the domain and range of each inverse. So notice I have 2 words here. I have original, and then I have inverse. So what I want you guys to do, I think the easiest way to do it personally, rather than looking at the equation, might be to graph it. So go ahead and open up Desmos on your computer and graph each of these and see if you can identify the domain and range from the graph. And I'm more than happy to answer questions on this. So go ahead and take a few minutes and work on that and identify the domain and range of the inverse once you find the original domain and range. Got the answers written right there. Okay, but again, that's where the domain and range comes for all of these problems. So for quadratics, really key that the domain in any quadratic function is always going to be negative infinity to positive infinity. That's a good key takeaway there. And then when you're finding the inverses, remember you just switch them. So I think the hard part is finding the domain and range of those originals. Inverses should be a lot easier. Okay, I think that covers everything for today.